Sanjeev Mohan is an industry analyst. He's been around for a long time in that space. He's an author. He's the author of Data Products for Dummies. So I want to welcome to the stage Sanjeev Mohan.
I walked into this venue, and what do I see on Market Street? There are banners on Nvidia GTC conference that took place in March. Why are these banners still here 2 months later? It's because it was the biggest thing that happened to this city of San Jose. The whole world was fixated on Nvidia. Elderly family members of mine are talking about Nvidia as if they've known about Nvidia as this brand new company that's worth $2 trillion and has done wonders in this world of something that they don't even understand called AI. But I'm not here to talk about Nvidia. My point is that we know in this room, all of us have known Nvidia for a very long time. But how did we know of Nvidia? We knew of Nvidia because these spoiled kids who only wanted to play video games wanted an Nvidia GPU graphics accelerator card in their PCs. That's all Nvidia did for 20 years. And then in 2017, attention is all you need, paper came out, transformer architecture happened, and Nvidia found itself at that right moment. Why am I bringing this up? Is because I believe that today, right now, this is an inflection point for real-time analytics and streaming data. I think this space, new space, which has been around for decades, has arrived. And I'm here to talk to you about this because what happens every time there is a new category in IT, people flock into the space. All of a sudden, there are many different approaches. There are a lot of subtleties, nuances, a lot of products, a lot of vendors, and it becomes very, very confusing. So as an analyst, this is my duty, this is my job to demystify whatever space I'm researching, and I'm honored to talk to you about real-time analytics. So let's get started. I'm going to skip this slide because Tim's already done the job for me and get straight to why do we need real-time analytics. Now, I want to be careful here because yesterday, Kishore's entire keynote was on this topic, and he eloquently explained the rationale for real-time analytics. I'm not going to repeat what he has said. Please watch his keynote from day one of RTA Summit. But just a summary of a few things that are different now. So first of all through my years, we were doing real-time analytics behind the scenes. They were actually meant to cater to IT departments. All of a sudden, COVID happened, we were locked down, the whole world went remote, and it became really important to start doing real-time analytics for the users. I have come to this very interesting revelation, and some of it is because of LLMs, that in the past, whenever I did data security, when I first got into it, it was all role-based access control. How many of you remember RBAC? Okay, so quite a few of you. Then it became attribute-based access control, policy-based access control. But now what we've learned is that the most effective way to secure something is by understanding user behavior in real time. And there is no match to that. So this is how the technology has advanced and why user-facing analytics have become important. We cannot forget that operational decisions still require to have the most current, fresh data that's available. By doing user behavior analysis, our anomaly detection has improved. Because we can now find out how, without even having the policy and rules, how things are a little bit off from the way pattern recognition was established. So we see that there are new approaches to anomaly detection. Customer satisfaction is, by the way, it's not just customer satisfaction, it's developer experience, it's administration, ease of administration, all of that is really important. Being able to give timely recommendations, and then going back to IT. If we have real-time data of what is going on inside our systems, then we can better manage resources. One of the most important things since last year and this year is not AI, it's cost optimization. Because we are going through some economic downturns and headwinds. So every company is looking to optimize costs, and this is one more area where real-time analytics become the linchpin. Let's get to how do we achieve these goals. My biggest main passion is in data management, because everything that we do, whether it's real-time analytics or it's generative AI, if we don't have the right data, then nothing will get done. So organizations that are looking for real-time decisions, they've got some major imperatives. The first one is they want access to fresh data, but in a cost-effective manner. I was quite amazed to hear Kishore yesterday when he said that real-time analytics has gone from being a more expensive option to becoming cheaper than doing batch analytics. So organizations that want real-time analytics do not want to break their bank. How do you avoid that? One way is by having a streamlined architecture, because it's how many of you remember Lambda architecture? Anyone? Yeah, so same hands. The Lambda architecture came out with a lot of fanfare in the early days of big data, and there was a speed layer, a batch layer. Wait, I've got to maintain two different stacks, copies of data to do, and then keep sending them across. In fact, the reason why we have ETL is because we've always had these operational transactional systems and analytical, then we have to kloosh them together. ETL jobs break without telling you. You just come to the office in the morning, the CFO looks at the dashboard and says, these numbers are not right. What does a CFO do? There is no single point of accountability. You start finding out what happened in my nightly batch job. Somebody says, oh, I don't know, maybe SAP, ERP gave wrong data. No, SAP was correct. Okay, maybe it's Fivetran, job failed. Maybe it's a DBT, data transformation. Maybe it's a Looker job, and it goes on and on. So having these separate stacks for batch and real time and trying to bring them together has not really, it's very error prone and it's problematic. The last thing that organizations want is they want to know if their sensitive data or intellectual property has been secured. Because now we live in the realm of GDPR, CCPA, and all of these regulatory compliance. So understanding how secure is my sensitive data becomes really important. So this is what the businesses want. Now let's pivot to, I'm going to talk to you about 4 different options of how we do real-time analytics. All 4 options have a place in the world. It's not like one is better than the other, but they serve different use cases. So we're going to talk about what are these options, and then we will talk about how does the product landscape look for these options. So let's start with the first option, which is not exactly real time. A lot of times we use BI tools to do analytics. These BI tools, by the way, typically will make a copy of data on the desktop for efficiency reasons. But that data is now stale. It has to be constantly updated. So it's not a real-time option. However, we know that there are new breed. We know that Power BI can have a direct connect into the data source and can do real-time analytics. But that is limited. And it's limited because the amount of transformation that we may want to do is not always there. Also, it may not be able to support the concurrency of very high number of users. So typically, using an ABI here stands for Analytics and BI platform, this is more of an offline. So to get beyond this, we started with the event stream platform, event stream processing option. Event stream processing or ESP is quite a game changer because now I can do very advanced transformations. For example, I can get data from Kafka, multiple streams from different sources, and I can process it in one place before I do analytics. I can join topics from different sources. I can do aggregations. I can say that as you are joining these, enrich my data, calculate the average value, and then I can do analytics on it. Also, I can write it to a downstream database. I can say that after I've transformed, processed my streaming data, I want to write it into Snowflake, because my real-time dashboards are based on that. I can also say, for my machine learning use cases, please write it also to Databricks. So all of a sudden, I've got multiple paths that I can write. And oh, by the way, when you write to Snowflake, put it in the Iceberg table format. And when you write it to Databricks, put it in the Delta format. And while you're at it, also go update Unity catalog. So this is the power of an event stream processing. In fact, the de facto standard for this space is Flink. Why I'm bringing up Flink is because I am going back to my traditional ETL days. Remember how I told you these jobs break at night, and then we go through this expensive root cause analysis to find out what broke? In fact, we now have a new category, relatively new as of 3-4 years old, called data observability. Why do we have data observability? It's because we couldn't figure out, we didn't have the transparency of what was breaking where, and we needed to have another 20 new products come into this space to help us decipher what's going on between the source and the target. But when you have a product like Flink, and you say, I want exactly once processing, if something breaks in the pipeline, it recovers. As opposed to an ETL, it may write half the message, and now I have inconsistent data I have to roll back. So Flink will help you checkpoint. It has fault tolerancy. It has elastic scale. In fact, I even think that event stream processing does not even do justice to everything that this platform does. For example, it has a whole suite of governance. Catalog, lineage, data access governance, all of that is built into an event stream processing. So it actually simplifies it. Some vendors that I've talked to here are even taking it to the next level, because Flink can get complicated if you do everything at code level. So they're building out an abstraction. So I can create table as select, and it just writes my streaming data into my downstream database. So this is for data in motion. So data in motion, processing it, making it ready for analytics is what event stream processing does. But not always do we need to have data in motion. A lot of times we need to go to historical data, and we need many years of data to be able to find out what are the patterns over the last few years. And that takes us to option number 3, which is stream-enabled database. Here, we take the stream and we land it into a database. This database is a real-time database. It has the ability to ingest streams in real time, process that in real time. So with like the window functions, like tumbling, sliding windows, be able to do aggregations, and then make it ready for analytics. This database, we will talk more about it, because this category also has 2 subcategories. Anyone who's in database management system knows that we have operational transactional databases, and then we have analytical databases, right? So same thing in stream-enabled databases, we have 2 different types. But I'm going to hold that thought for now. We will look at it when we go look at the product landscape. So this is the data at rest option for us to do real-time analytics. That takes us to the final category, and this category is what we call as Unified Real-Time Platform. This is a name that some of us got together, we wrote a white paper in January, and then we followed it up with a white paper that came out just a few weeks ago. In fact, my co-author is here. His name is Manish. He was a chief product officer at Hazelcast. So he and I collaborated with one of my ex-Gartner analyst, Roy Schulte. So a unified real-time platform actually is a culmination of three different things. It is the event stream processing, a real-time database, but also with application enablement, the ability to create domain-specific applications. So when you bring all these three together, then that is what we call a unified real-time platform. A unified real-time platform also is real-time, but not just data at rest, but also data in motion. So it's also unifying different aspects of doing analytics. So I'm going to summarize this first part of my talk. Gartner, ex-Gartner analyst, Magic Quadrants, creating 2x2 tables is something that I even dream. I think my dreams are in like 2x2s. So I created this table just to sort of bring all this together because all these different options. So I created two vertical columns, real-time batch, and then data at rest and data in motion. So I'll just walk through this. Streaming analytics primary use case is batch, although we see streaming analytics also now happening in real time as long as it's not large velocity of data, we can do it. Event stream processing reverses it. Event stream processes, the primary use case is data in motion in real time, and people stop there. But that's not true. I can always replay the messages that are sitting in my Kafka topics. So I do have some capability to do batch analytics also for event stream processing. Now, when we go to option number 3, which is streaming database, just because it's a database, it's a data at rest. But because it's a database, it's stream enabled, so obviously it does real time, but it also now has ability to do batch analytics because that data is persisted in that database. The last option that I introduced to you is called Unified Real-Time Platform. It is real time and it does it for both in motion and at rest. So that takes me to the second part, and this is where Manish and I went out, we looked at, in fact, most of the vendors that are outside, some of you are confused as to how are they different and what do they do. So this is where we started to categorize what are these vendors, products, and which category do they fall into. To do that, it takes me to the second part. So here, you see I've got 4 different hexagons. And I had to check, are these hexagons? I don't even remember the graphics. But these are not exactly what I just shared with you, the 4 options. I took out option number 1, which was BI. And what I did was, remember I mentioned I'm going to break the stream-enabled database into operational and analytical. That's what I've done here. Important thing to remember is that all these 4 options are getting data from some message bus or a web socket, a web hook, and they're using protocols like either Apache Kafka directly or Kafka-like. There's so many now companies that provide Kafka-like options, or it could be MQTT for IoT devices, it could be Pulsar, it could be Solace. Every hyperscaler has their own protocols that they support. So they feed data into these 4 different options. I have spoken to many clients that have actually all 4. In fact, large banks, multinational banks have all of them. So once again, these are not separate categories. These complement each other. Let's go through each one of them one by one. So we will start with event stream processing. This is the domain of Flink. I have to thank, there are many companies mentioned here. I'm not going to go through each one of them, but one company that I do want to point out is Confluent, because Confluent really helped pave the way first for Kafka and now for Flink. And it's made Flink the standard that it is today. And but there's also Spark. Spark was never ever meant to be real time. So they were always micro batch, but they do have an option, although not that popular. But structured Spark streaming does have event stream processing capabilities. A few things that I want to mention on this slide, and for the next 3 slides, you will see the list of products that you see here is a representative list. We could not possibly add every single vendor onto this. The second thing that I also want to mention is that this list is in alphabetical order. Again, something that Gartner drilled into me because I cannot be taking any preferential stance and trying to promote a product. So, and the third thing that I also want to mention is I have been in this industry, IT or data, for over 30 years. The pace of change has never been this frantic. So everything that I'm going to share today, I want you to treat it as a baseline. I want you to look at this and go, okay, I have an idea of what you do and where you are, but things change. Companies get into other spaces, they expand. It's a very dynamic space. So please do your due diligence as you go into these products. That takes me to the second hexagon, which is, if you remember, streaming database for OLTP, or operational and transactional. So I've got 3 companies mentioned here. Once again, by the way, I've spoken to these companies, and they have, some of them have already told me, well, we don't really do a lot of what you're saying. We actually do event stream processing. So once again, do your own due diligence. Another interesting thing that I've also noticed is at this conference, there have been a number of talks where people have compared these products and said, oh, wait, that's Java, I'm C++, and that's Rust. So there's a very, technically, a big comparison that goes on, ease of use, deployment options. Is it in my VPC or somebody else's VPC, scaling, performance? So there's a whole evaluation criteria. But there are 3 companies that I've mentioned here. If you want the freshest data in your database, then this is a place you go. This is millisecond option. This is where you start seeing window-based SQL becomes really important because you're acting on data as it's coming in. In fact, the data comes in through some message bus or WebSocket, and you start materializing that into a table. So using technologies like differential data flow and some other ones, you're basically making the streaming data available for analytics as quickly as you can in literally milliseconds. You are not acting on the vast amount of data that's already stored in your database. So why do you use streaming database? You use it for alerts, notifications, anomalies, recommendations, dynamic pricing. So there are a number of these use cases for which you use a streaming database. On the other hand, we've got streaming-enabled analytical databases. These databases are slightly different. These databases literally act upon petabytes of data accessed within seconds. So for example, let's say I want to see the rank of all the of a leaderboard. Now I've got 2 years of data. I cannot do it in stream-enabled database, the previous option, streaming database, because that one is very much real-time, freshest data. If I want to look at 2 years of data, I want to do scans, for which I need indexes. In fact, you don't even need a type of index like a B tree or a bitmap. You need a variety of indexes depending upon what kind of database it is. A lot of these databases typically are columnar in nature. So just like OLAP databases, and we have quite a few databases mentioned here. So for aggregations, for very fast lookup. Also, the databases in this category are also known for high concurrency at very low latency. So petabytes of data, high throughput. So in fact, it's very interesting. Sometimes I'll see these benchmarks. Oh, I support so many queries per second, and so supports so many fewer queries per second. But what they don't say is that not every query is exactly the same. Some queries that go on streaming database are single row. But queries that go on in this category of analytical databases are also doing a lot of aggregations, and they're basically multi-row. And so be very careful when somebody says my QPS is higher than their QPS. Drill down into what kind of queries are you talking about, and how much throughput is happening. StarTree, I'll just call them out. I don't want to call them out, but I'm grateful that they invited me to this conference. They're hosting this conference, but a number of these companies are around here, or their representatives are here. That takes me to the very last category, which is called Unified Real-Time Platform. You see there are a lot of companies in this space. Remember, this is the space that is bringing event stream processing, real-time database with application enablement. And in fact, the document that Manish and I wrote, it's on my Medium blog post, my Medium site, which is sanjmo.medium.com. We actually list out far more products in this category, and those are solutions that are built on top of a unified real-time platform. Again, a lot of these companies are right outside, and with this, I come to an end of my talk. Just a quick conclusion. We've talked about real-time analytics, but please remember a lot of these things rely on some message bus that was not part of my discussion, and that's most likely Kafka. Each option exists because they serve different use cases. And then we talked about URP. One thing that I have not talked about, which is very unlike me, is generative AI. I really feel that the next focus of streaming analytics is going to be generative AI. If I'm an end user and I'm talking to a chatbot, or I'm sending a text and I expect it to write my SQL, or I expect it to create me an image or summarize my document, I want it in real time. If I don't get it in real time, I am not going to play around with that too long. Now, I know that the traffic going to OpenAI or some Hugging Face model and then bringing the results back can be time consuming. In fact, even then, what I sometimes do is, when I write a document, I upload it to ChatGPT or Gemini, and I say, proofread it for me, and point out all my error mistakes, and there are lots of them. You know what it starts doing? It starts showing me, line by line, what's wrong, what's wrong. It's not waiting to process the whole thing and then send it to me, because that would, Tim Whale from StarTree yesterday talked about the impatience economy, the other Tim. So that's the world we live in. We have very tiny attention span thanks to social media and mobile devices. So real-time streaming becomes imperative. In real time, I want my text, my natural language to get embedded, do the vector search, return the results to me. Thank you so much. You've been an amazing audience, and it's been a pleasure talking to you today.